Okay, so one thing that I had issues with in organic chemistry were synthesis problems. So the way a synthesis problem works is basically you have to figure out how to get from point A to point B. So we got to figure out what we need to react with in order to get this product. So the thing that I found the easiest was to identify what part of the starting material was still in the product, which, as you can see by looking at it, is this portion. So, another way that I figured out to make synthesis problems easier was to start by going backwards in some cases. So, in this case, it would actually help. So we know that we gotta basically go from this to maybe something else to this to this. So what we're gonna have down here is this part of the original reactant and something else. So we're gonna make something with a good leaving group, so I'm just gonna make it tausyl chloride. So, how do we go from here to here? Well, basically you just have to know that one of the easiest way to do that is to have a sodium ion and then add on whatever else you need. So you add on the alkyl ethyl with a methyl. So that's how you go from there to there. So now we're going to need to go from here to here. Well, we know that we can't really do that in one step, so the easiest way to do that would be to have this, but there had to be something else here before the tausyl chloride. So we know that we had to add the tausyl chloride in. And since tausyl chloride is always paired with pyridine, we write that. So what did we have here? Well, really, we could have anything that was a bad leaving group and make it into a good leaving group. So for this, I'll just choose a hydroxyl group. So then the last step is to go from here to here. And this is probably the trickiest way to do it. Since this is a primary alkene, we know that we have to somehow get rid of that, and typically most reactions want to do the Markovnikov addition and add to the most substrated. So one reaction that does not want to add to the most substrated and wants to add to the least substrated would be an oxymercuration reaction. So with this, we just add all this with H2O, and then in order to make sure it does what we want, we add sodium with a BH4. And that's how you do a synthesis problem. Okay, so two other things that I had an issue with were, one was knowing substitution versus elimination. And you know, if you had one thing, then how would you know which was which? So you know that if you have a sterically hindered base or a sterically hindered substrate, that favors more elimination than substitution. High temperatures favor elimination, and then good nucleophiles that are weak bases favor substitution over elimination. So that's one. Another one that I kind of had an issue with was hydroboration. And the main thing that you have to know with that is that it adds the boron to the less substituted side of the molecule, and there's no carbon cation formed, because if there was a carbon cation formed, then you would get this scrambling of the stereochemistry of the molecule.